So
Which
that's a long
it's like it's so powerful, it's weirdly slow at one level. I mean, you wouldn't even notice, I think you were saying before, you wouldn't even notice falling into that event horizon if you were there.
Yes, so you may have heard of spaghettification, where you fall into a black hole and the gravitational field on your feet is much stronger than on your head, so you're ripped apart. This black hole is so big that you're not going to become a spaghetti noodle, right? You're just going to drift right through that event horizon.
So it's like a giant tornado. When Dorothy was whipped by a tornado, she ended up in Oz. Where do you end up if you fall into a black hole?
Vancouver.
Oh my God! It's the red circle. That's terrifying.
Here we are. No,
really.
Black holes really are the central mystery of our age, because that's where the quantum world and the gravitational world come together. What's inside is a singularity, and that's where all the forces become unified, because gravity finally is strong enough to compete with all the other forces. But it's hidden from us. The universe has cloaked it in the ultimate invisibility cloak, so we don't know what happens in there.
So there's a smaller one of these in our own galaxy. Can we go back to our own beautiful galaxy across? This is the Milky Way, this is home, and somewhere in the middle of that, there's another one which you're trying to find as well, right?
Yeah, well, we already know it's there, and we've already taken data on it, and we're working on those data right now. So we expect or hope to have something in the near future. I can't say when.
It's way closer, but also a lot smaller, and so maybe the similar kind of size to what we saw up to.
So it turns out that the black hole in M87 that we saw before is 6.5 billion solar masses, but it's so far away that it appears a certain size. The black hole in the center of our galaxy is 1,000 times less massive, but also 1,000 times closer. So it looks the same angular size on the sky.
And so finally, I guess, a nod to a remarkable group of people. Who are these guys?
So these are only some of the team. We marveled at the resonance that this image has had. If you told me that it would be above the fold in all of these newspapers, I'm not sure I would have believed you, but it was, because this is a great mystery, and it's inspiring for us, and I hope it's inspiring to everyone. But the more important thing is that this is just a small number of the team. We're 200 people strong, with 60 institutes and 20 countries and regions. If you want to build a global telescope, you need a global team. And this technique that we use of linking telescopes around the world kind of effortlessly sidesteps some of the issues that divide us. And as scientists, we naturally come together.
I want this one. What? Can a black hole be destroyed? That one. Make it a little big, that one.
في مجالات شتى بدءاً من الرياضيات والطب ومروراً بالهندسة والعمارة ووصولاً إلى الفلك والفلسفة.
Black holes are among the most destructive objects in the universe. Anything that gets too close to the central singularity of a black hole, be it an asteroid, planet, or star, risks being torn apart by its extreme gravitational field. And if the approaching object happens to cross the black hole's event horizon, it'll disappear and never re-emerge, adding to the black hole's mass and expanding its radius in the process. There is nothing we could throw at a black hole that would do the least bit of damage to it. Even another black hole won't destroy it. The two will simply merge into a larger black hole, releasing a bit of energy as gravitational waves in the process. By some accounts, it's possible that the universe may eventually consist entirely of black holes in a very distant future, and yet there may be a way to destroy or evaporate these objects after all. If the theory is true, all we need to do is to wait. In 1974, Stephen Hawking theorized a process that could lead a black hole to gradually lose mass. Hawking radiation, as it came to be known, is based on a well-established phenomenon called quantum fluctuations of the vacuum. According to quantum mechanics, a given point in space-time fluctuates between multiple possible energy states. These fluctuations are driven by the continuous creation and destruction of virtual particle pairs, which consist of a particle and its oppositely charged antiparticle. Normally, the two collide and annihilate each other shortly after appearing, preserving the total energy. But what happens when they appear just at the edge of a black hole's event horizon? If they're positioned just right, one of the particles could escape the black hole's pull, while its counterpart falls in. It would then annihilate another oppositely charged particle within the event horizon of the black hole, reducing the black hole's mass. Meanwhile, to an outside observer, it would look like the black hole had emitted the escaped particle. Thus, unless a black hole continues to absorb additional matter and energy, it'll evaporate particle by particle at an excruciatingly slow rate.
No.
How slow? A branch of physics called black hole thermodynamics gives us an answer. When everyday objects or celestial bodies release energy to their environment, we perceive that as heat and can use their energy emission to measure their temperature. Black hole thermodynamics suggests that we can similarly define the temperature of a black hole. It theorizes that the more mass...
Wait, where is here? Can you
That
explain?
one. It's
You
this.
showed them in your mouth.
Wait.
For Asma or for me or for Eli? Ethan. You want this?
Can you please help me?
Avocado. You try.
I'm trying to explain.
Okay, sorry. Go ahead.
Now where? Can you? Hey, what is this little island? Let's check that little island. That one in
Can control
Zealandia.
here, oh. Come on.
No.
This one?
I didn't see.
I'll teach you. I'll
Make
teach
it
you.
bigger.
Like this?
No. I'm seeing the half of Africa.
Then you can move up. You can move up like, move down like that. Where?
Go left. Go there. Go there. There. Put it up. Put that. Make it bigger. Make Zealandia bigger. Make the 8th continent bigger.
Wait now.
How about Fiesta?
Hmm?
There. Fiesta.
Where?
Yeah. This one.
Vesta?
Yeah.
That's already space. You are in the outer space.
Yes!
You like that?
Cool! Oh! Nice! Okay, guys, we are in Fiesta. Now let's go to Io. Cool!
You can make it.
Mercury.
Your lab. You like it?
Yo! Mercury is cool!
Wow. Is that cool?
Yeah.
I don't find it cool.
Oh, also you can find Olympus Mons in here. Oh, those are the craters. Can you come here?
Where?
Here, no, here.
Wait. I cannot move it. That's the maximum. Let's try on the other side. Maybe here.
Make it bigger.
Oops. What's happened?
Sorry, guys. Google Maps. Can we go to there? Here?
What's that?
Enceladus.
Enceladus.
It's white.
That's what is in there.
Can you make it bigger?
Yes.
No. Smaller.
Okay. Like that?
No, like the planet Earth. You make it big.
I cannot. Only like this. This is only the space. Like for you to be able to see what is inside. Only like this.
Oh, how can you come here in Mustafa?
You know this?
Yeah. I read it. This is Raya, Mustafa,
Huh?
and
You know
Hassan.
that? Really?
Yeah.
Oh my god. I don't know that. Those are only name of Arabic people.
Yeah. Can you make it? Can you make it bigger? Make it bigger. Not like the planet.
That? Or like that?
Yeah, like that. This is their planeta. Erebonidersum Fadorsa. This is Mayatsusi, Bulacus, Bahman, Kamar,
Wow, you
Saint
know it?
Susi, Zumrud, Mustafa, Al-Mustasi,
How come you know that?
and Mersusi. Showed ya!
You know it, really?
Okay, now let's go to moon.
Let's if I'm going to show you this.
There are many things here. Let's go move. Okay, how can can we go to... I want to go to Pluto. I want to go to Pluto. Where's Pluto? Mercury, Venus. Whoa! So hot. Earth with life. No. What am I seeing now? The International Space Station. Wait.
What's that?
The International Space Station.
Really?
Yeah.
You know that also?
It's Copula. It's named the Copula. I want... Wait. I'm going wrong. Oh. Can we go to Europa? Let's go to the Europa.
Europa.
Yeah, that's the Europa. Europa is... What is Europa? Smallest of the 4 billion moons of Jupiter. It's also the moon of Jupiter, and it's really big. The biggest moon on Earth to ever live. Okay,
Really?
let's do... Hey, when I talk... Hey, can you fix it? See?
Yeah, I'm fixing this set movie. What do you want?
Can you see?
Where? Huh? This one?
Yeah?
Set movie? This one?
I see like that.
What?
See? It always does like that one.
Wait,
When I talk...
it's delay.
Mm-mm. Guys, wait. Short talk. Into Sinji.
No, it's okay.
Okay.
Where are we? There's a little bit of delay. Okay? Go ahead, go. Don't mind that.
Delay.
Only look here.
Okay, now where am I? Okay. Let's go to the first planet from the sun. Okay. I wish I could see Pluto in here. Can we see Pluto? How can we go up? Let's go to Vista. Oh yeah, there are many in here. This is Mamla. It's like Manila. It's like vanilla. Manila is like vanilla. Let's go to Earth so you can see can you see Philippines? Place where you live on. Wait. Okay, let's go. Ah! I saw something.
Go ahead.
There's damage.
No, it's on the cam. It's totally fine, don't worry. Go ahead.
What is happening? Why can I see that orange thing? There's no orange thing here. Stop it! Stop it from seeing the orange thing. I don't want to see that orange thing. It's bad. We don't even have an orange thing.
It's here.
Oh.
You don't know? Don't remove, that's mine. That's my stuff.
So we cannot see orange. I don't like to see an orange thing here. Okay, guys, back to the question.
Okay. Where are you now? What are you? What country? What planet are you? Mars?
No,
You wanna see moon?
No, in Io.
Are you? There we go.
Yeah, let's go to the hottest.
Is that the hottest?
No. Boom! Hottest Venus.
Wow.
Okay.
What can you say about Venus?
You can't go there. You can't go on Venus, man.
Huh?
You can't go on Venus, but you can go in Earth. You can go in Mercury and Earth. We're already here. International Space Station. International Space Station. Where is the? Okay, let's. I'm a little bit. International Space Station. Wait.
You're on the International Space Station already?
How can I remove that picture?
Yeah.
I'm going to Earth.
What picture you want to remove now?
That one, the International Space Station one.
Wow, it's nice. Yeah, no? What do you want?
It's Mercury. We're going to Mercury, Earth.
What
No,
one?
Moon.
Moon?
You can go to Mercury, Earth, and the Moon.
Okay.
Moon.
Wait, anak. Nawala yung itong cam.
That's Mercury. I said go to Moon, not Mercury.
Moon?
Yeah, Moon.
Okay. Okay.
And Mars. Cool. Fiesta.
Enjoy, anak. Kiss mo na kita.
Okay.
Matutulog mo na ako. Wala pa akong tulog. Love you.
Okay. Fiesta.
Just don't click anything, ha? And then you don't know what to do. Okay?
Series. Okay.
Enjoy.
Io. Europa. Ganymede. Callisto. Mimas. Mimas oral is bad. Callisto and Mimas. Enceladus. Okay. Guys! Pa! Something is wrong! Something went wrong!
What is up?
The delay and also the picture. The delay and picture.
What? Yeah.
See? It's only one. I'm testing the whole one. I wanted to get to Aries and Pluto.
Mm-hmm.
Where's Aries? I can't see Aries in the names. I can't see Aries in the names. See? Where's Aries? And I can't see Aries. I can only see Mercury, Venus, Earth, International Space Station, Moon, Mars, Vesta, Ceres, Io, Europa, Ganymede, Callisto, Mimas, and Enceladus. Is
It's gonna like this.
Okay. Let's do it.
Let's make this one.
What is Thetis? Can I see this? Thetis?
Wait lang, anak. Hindi napigil.
I want to get to Aries. I want to get to Aries and Pluto. Where's Aries?
Wanna go there?
Yeah, Aries the 10th planet from the sun.
Really?
Yeah. His moon is Dysnomia. His name is Aries.
Aries. Who's Aries? Where?
Mercury, Venus, Earth, Mars. I can't see.
It's letter A. Wala.
It's E.
Ceres.
I said Aries, not Ceres. They're alike.
There was nothing.
Pluto! I want to get the Pluto. Here's Pluto. The lost planet. Hey, can I? Hey, what is this? Is this water?
Don't click too much.
It's water. Why is there water in Pluto? Pluto does not have water.
Really?
Yeah. Oh, Sharon.
Can you sleep na?
Here's Sharon. What?
Can you sleep na na?
Yeah.
Love you.
There is still water on Sharon.
Love you.
Love you too.
See you later. Don't call me na.
Huh?
Don't call me na na. Just call
Okay.
mama if you need something.
Okay, what is Tetos? I think it's Tetis. Titan. You can go to Mercury. Earth. International Space Station. Cool. Let's get in. Cool. Where are we going? Hey guys. Cool. Okay. Oh, poor Pluto. It also has a heart. You can see the shape of a heart. It's located here, see? In there. If you can see it, you can see that it's in here. You know that it's in delay, but it's okay. You can still see me. Okay, so let's go with animating. Whatever the Titan! It's not a cookie, man! A cookie for Venus! I didn't say curse. Sharon. Okay, let's go to the Let's go to planets. Okay, let's see Mercury. Here's Mercury. This is Mercury, the planet from the sun. You can see the half one. Okay, Mercury. Okay, let's go. Okay. Okay, this is Mercury. Let's go to Google Maps and see Mercury. Oh, this is really Mercury. You know what? Let's go here. If there's an island to look. I did not know there were so many planets. That's the South Atlantic Ocean. Wait. I'm coming back. Mama, can you give me yogurt? Guys, I'm back. I'm back with a drink. That from my fridge. Okay, let's go. Wait, I'll drag myself. Okay, let's do it. We're okay. Where the heck am I? He was. Okay, let's go to Botswana. We're in Argentina. As you can see, this is Falk Island. And this is the canyon. Okay, let's talk about more canyons. It looks like it's not a canyon because in the picture you can see it. That it's like a canyon, but that it's not a canyon. But I can actually see 3D, so that's 3D. And also, what the Google Map says, that it's true. That is also, that is That's not what I'm living on. I'm living in Qatar. I'm going to Philippines, and I'm going to Canada. I'm going to live in Canada. So I'm going to be Canadian, and also I'm going to go there in Falk Islands. I talk too much. Hey, what in the heck? Pa! Something's wrong!
Rose?
You have to be with me.
Careful kasi sa pagpindot. Na-close mo.
Guys, are you? Can I stop the live streaming now? I want to stop the live streaming. I'm tired.
Where are you? Oh, they're enjoying. I can... What do you want else to see?
I want to know.
What? Tell me.
YouTube? I want. It's hard to tell.
Huh?
I want. Beetlejuice.
Huh?
Beetlejuice.
Yeah.
A star.
Beetlejuice? How to spell?
Like no, not Beetlejuice. Sirius.
You can type here. You know, right?
No, not sword.
Yes.
Seer. Or. Yes. Seer.
Serious Planet. That one?
Yeah, Sirius.
Wait. Let me just... What happened to you?
Images.
Wala na ka? Windows. Sure na walang Windows.
Sirius. There is 15 more stars.
Okay, where? Go. Okay na? Alip yun na?
Yeah. Ria.
Sleep na tayo.
Ria. That is right. That's Beetlejuice, Rigel, Arcturus, Vega, Canopus, Roni, Procyon. Let's see Procyon. What color is Procyon? Write in the descriptions. I will tell the answer now. White. Procyon's color is white. Procyon is a binary star in the Canis Major constellation that is yellowish white in color. Okay, if someone smart here is listening, then why don't you answer? Answer the video right now. Okay. Let's make this ordinary video here. And also, this is the first episode of Explore with Ethan and also Explore with Eli. Explore with Eli is the next episode later where I will, where Eli and me will tell you the solar system. Okay, and also he will teach you words. If babies are watching this too, then you shall watch, and also I will see Roni. Wait. This is Roni. Roni is there. There is Nidekeshra, Tornavasu, and also, let's see here. Nine-day-old moon, high age, Oliver. Wait, what? Okay, we have Sirius, Canopus, Rigel, Canervus, Arcturus, Vega, Canopella, Rigel, Procyon, Alkmaar, Betelgeuse, Hadar, Altair, Alpnix, Aldebaran, Arntes, Spica, Pollux, Fornacio, Tot, Deneb, Minimosa, Regulus, Adra, Shala, Castor, and Garox. We're here. Okay, we're done. Okay, let's see the What Are Continents video. Guys, wait!
How many continents are there? If you grew up in the English-speaking world, you might think that the answer is obvious. 1, 2, 3, 4, 5, 6, 7. But not everyone counts continents the same way. The usual definition, that they're large land masses separated from others by oceans, is fine until you actually start to think about it, and then you run into problems. Problems like this. Here's Europe, here's Asia, and you'll notice the lack of ocean between them. Then why are they two different continents? The usual reason for this split is a cultural one, that Europe is so different from Asia that it's best to pretend it's a separate entity. Okay, maybe. But if the cultural argument is valid, then surely it also applies to India and the Middle East. Now you have 9 continents and a new problem. If culture defines continents, then you'll never stop drawing increasingly unhelpful lines. So some places ditch the cultural division and combine Europe and Asia into Eurasia. This Eurasia is not to be confused with this Eurasia, which has always been at war with East Asia. Making Eurasia gives a 6-continent view of the world. But what about over here, North America and South America? They're connected to Panama, or at least they used to be until Teddy Roosevelt decided that someone had to cut that country in half and it might as well be him. But even still, the canal's only 13 meters deep. You could walk all the way from northern Alaska across the narrow Panama Canal and, if it weren't for the deadly, impenetrable, poison-filled Brazilian rainforest, make it all the way to the southern tip of Chile. So North and South America, despite the canal, aren't really divided. Which is why some places, particularly South America, treat America as a single continent, not 2, which brings the total number of continents down to 5. But if you disregard the Panama Canal, then you also have to disregard the Suez Canal, and you've just created the monstrously large Afro-Eurasian continent, 85 million square kilometers, home to 5.7 billion people. With this four-continent view of the world, we must surely be done because there are no more continents to merge and our definition from the beginning is now consistent. Except we're not done because of that troublesome word large. Exactly how large is continental large? Is Australia really a dinky continent or is it king of the islands? Why not make Greenland the smallest continent? It's pretty big, even if you took away its ice. And speaking of ice, what about Antarctica, smallest continent? It's pretty big, even if you took away its ice. And speaking of ice, what about Antarctica, the forgotten continent unfairly smushed against the bottom of maps just because no one lives there? Remove the ice sheet that covers Antarctica, and you reveal it for the archipelago it really is, not the single landmass it pretends to be. And to complicate matters, the largest of these Antarctic islands is smaller than Australia. So if you want to keep calling Antarctica a continent, then there's a bunch of other islands that might want to be continents too. Islands like New Guinea, Borneo, Madagascar, Baffin Islands, Sumatra, and Honshu. While this seems inclusive to the point of silliness, ultimately someone has to decide what large means, and that's going to be an arbitrary line. This problem will be familiar to anyone who remembers the is Pluto a planet or not a planet fiasco, which hinged mostly on this same issue of size. So now we're more confused than before we started. There might be 3 continents or dozens. You know what will sort this out? Science. Confusion plus science equals answers. Let's ask a geologist what a continent is. For them, a continent is a tectonic plate, part of the Earth's crust that move together. So geologists, show us your continents. The Antarctic plate, the Australian plate, the Eurasian plate, the South American plate, the African plate. So far, this is looking pretty good. The Middle Eastern plate, the Indian plate, the Caribbean plate, the Pacific plate. There isn't even anything there. Well, there's mostly nothing there. The Nazca plate, the Scotia plate, really? At least North America is still looking reasonable, until you include a chunk of Russia, half of Japan, and half of Iceland. Well, this is unhelpful. Thanks a lot, geologists. The heart of the problem is that the word continent doesn't have a simple and consistent definition for everyday use. So how many continents are there? Well, how many do you want there to be?
Okay, that's done. That's the continents, and now let's go to the planets. Is Pluto a planet? Yeah.
Pluto, planet or not? Before we can answer this question, we need to know what the word planet is for, and that takes us back to the ancient Greeks who called Mercury, Venus, Mars, Jupiter, Saturn, the Moon, and the Sun planets. Basically, if it moved across the sky and was bright, it was a planet. This is a terrible start for the word because 1, it excludes Earth from the list, and 2, it groups wildly different things together. But the Greeks couldn't know how different the Moon was from Saturn because the best technology they had to observe the universe was sadly limited. It would take several thousand years until the industrious Dutch made the first telescopes and astronomy became much more interesting. Astronomers could now confidently rearrange the solar system, an elegant scientific advance that no one could possibly object to, and reclassify its parts, dropping the Sun and the Moon from the list of planets and adding Earth. Now, if it orbited the Sun, it was a planet. As time went on and telescopes got better and better, each new century brought with it the discovery of a new planet, which brings us to this familiar solar system, 9 planets orbiting 1 star. Looking at this model makes people wonder, why do astronomers want to ditch Pluto? The problem is pictures like this in textbooks are lies. Well, not lies exactly, but unhelpful. They give the impression that the planets are similar-ish in size and evenly-ish spaced, but the reality couldn't be more different. Here, dear Terrans, is our home planet Earth, and this is Jupiter next to it at the correct scale. Rather bigger than you probably thought. If we take this diagram and adjust for the correct sizes of the planets, it looks like this. Unless you're watching the video in full-screen HD mode, you might not be even able to see Pluto. So size differences are vast, and Pluto is the smallest by far. But it's not just small for a planet, it's also smaller than 9 moons. Triton, Europa, our own moon, Io, Callisto, Titan, and Ganymede. Even if you show the correct relative sizes, the distances are still a problem. Think about it, if Jupiter was this close to Earth, it wouldn't look like a dot in the night sky, but would be rather overwhelming. So it must be really far away, which makes drawing it to scale rather a challenge. If you want the length of a piece of paper to represent the distance from Mercury to Pluto, then giant Jupiter would be the size of a dust mite on that page, and Pluto a bacterium. But excluding Pluto from the Planet Club just for being tiny and small isn't reason enough and quickly brings out the Pluto defenders. In order to understand what Pluto really is, we need to first discuss a planet you've never heard of, Ceres. Back in 1801, astronomers found a new planet in the huge gap between Mars and Jupiter. It was a small planet, but they loved it anyway and named it Ceres. The next year, astronomers found another small planet in the same area and named it Pallas. A few years later, they found a third one, Juno, and then, funnily enough, a fourth one, Vesta. And for several decades, children learned the 11 planets of the solar system. But astronomers kept finding more and more of these objects and became increasingly uncomfortable calling them planets because they were much more like each other than the planets on either side. So a new category was born, asteroids in the asteroid belt, and the tiny planets were relabeled, which is why you've never heard of them. And it was a good decision too, as astronomers have now found hundreds of thousands of asteroids, which would be a lot for a kid to memorize if they were all still planets. Back to Pluto. It was discovered in 1930, making it the then 9th planet. First estimates put Pluto about the size of Neptune, but with more observations that was revised down and down and down. While Pluto shrank, astronomers started to find other similar objects orbiting in the same zone. Sound familiar? While school kids kept memorizing the 9 planets, some astronomers grew uneasy about including Pluto because the size estimates continued to shrink. They learned that Pluto is made mostly of ice, and they continue to find lots and lots of icy objects at the edge of the solar system just like Pluto. This problem could be ignored as long as no one found an ice ball bigger than Pluto, which is exactly what happened in 2006 with the discovery of Eris. Once again, astronomers recategorized the solar system and grouped these distant objects, including Pluto, into a new area called the Kuiper Belt. And that's the story of Pluto, a miscategorized planet that finally found its home, just like Ceres. But this story is really less about Pluto than it is about realizing the word planet isn't very helpful. The first 4 planets are nothing at all like the next 4, so it's even a little weird to group these 8 together, which is why they often aren't and are separated into terrestrial planets and gas giants. And now that we have telescopes that can see planets around stars not our own, and we found rogue planets drifting in empty space, and brown dwarfs, objects that blur the very line between planet and star, the word planet becomes even less clear. So as we increase our knowledge of the universe, the category of planet will probably continue to evolve, or possibly fall out of favor entirely. But for the time being, the best way to categorize the stuff in our solar system is into 1 star, 8 planets, 4 terrestrial, 4 gas giants, the asteroid belt, and the distant Kuiper Belt, home to Pluto.
Okay, let's see how to pronounce.
Hello Internet.
It's how
In my last video
to
about Pluto,
pronounce-
you may have noticed that I said aloud the names of every planet except one, this one. And that was no accident, but rather the result of careful script editing, because where I grew up, I learned that the name of the 7th planet is pronounced Uranus. Of course, to a kid, Uranus sounds an awful lot like your anus, which is how I and everyone else I knew ended up saying the name, which is funny when you're a child, but becomes a bit of a problem when you grow up and try to teach scientific facts about the planet. For example, Uranus has a ring around it. Astronomers have discovered a dark spot on Uranus. Uranus is a gas giant. Uranus is surrounded by methane. There is a solution to this problem, the alternative pronunciation of the name, which goes Uranus. And most scientists in public roles do use this pronunciation. But for me, Uranus is still problematic. Sure, it's better than Uranus, but it's still Uranus. And perhaps I'm just childish, but when someone else says Uranus, I still hear Uranus in my head, and it just draws more attention to the unfortunate name. The tragedy is, it didn't have to be this way. The 7th planet from the Sun is unique because it's the first planet we discovered. For all of human history, the 6 closest planets were big enough or bright enough to see with just our limited simian eyes. But the next planet was too...
Okay, I think I'm pronouncing Uranus or Uranus or Uranus. Okay, that's the pronunciation. They're wrong.
dim to see until our telescope technology got good enough for British astronomer William Herschel to spot it in 1781. Understandably, though, he didn't think he discovered a new planet since from the rise...
I think he said 1801. I think that's when the war started in United States. Pa! Something happened! A new planet? Surely not. Pa! Something happened! A new planet? Surely not. Surely a new planet? Surely not. New planet. I lost it. There's no sound.
What happened?
I can't hear the sound there. I can't hear the sound.
Where?
17.
Where?
That's still when the war started.
Because you are on mute.
Make
This one.
me not mute. Where can I... Saan? Okay.
Yes.
I can't see.
There you go.
Choose a name he must, and Herschel, being the good subject of the crown that he was, christened his new planet the Georgium Sidus, which means the Georgian star. And the George in that Georgian star was King George III, the reigning monarch. While King George liked the name, the rest of the world did not, and decided that perhaps Herschel wasn't the best guy to name the new planet after all, and quickly decided to come up with alternatives of their own. One suggestion was Neptune, which is confusing to us now, but at the time the planet
If you're done, don't forget to say thank you for watching, guys. Okay?
Okay.
But don't close, huh? Keep it
that would become Neptune had not yet been found. A more obvious alternative was to name the planet Herschel after the man who discovered it. Even in Great Britain, the name the Georgium Sidus proved a bit stuffy for some, so variants like the Georgian planet or just Georgium were also used. Though never, as you might have heard, George. Side note here, while researching this video, I found a lot of websites claiming that the 7th planet was almost named George, but I was never able to find a primary source for this. As best I could tell searching through documents from the time, no one ever suggested this name. I checked with the Royal Institution, who since 1799 has been promoting science awesomeness from the heart of London and whose videos you should now go watch, and they confirmed the name George was never on the table because to so casually refer to the king at the time would have been disrespectful, and disrespecting a monarch is never a good idea, especially one who is slowly losing his mind from a genetic disorder, but that's a story for another time. Anyway, another real suggestion for the new planet's name came from Johann Bode, who suggested the Greek god of the sky. When a colleague of Bode's discovered the 92nd element in 1789, he named it uranium to support Bode's choice and try and end the debate. Perhaps because these two were German, it might not have occurred to them how the word would eventually be corrupted in English. Though it's also hard to know how English speakers in the 1780s and 90s would have pronounced the name. But since the word anus was in the language then, it seems unlikely that this particular pronunciation would have been popular. It may also have been pronounced with a flat A to sound like Uranus, or something more like the Greek name Uranos. These names competed with each other over decades. For example, still in 1823, the Encyclopedia Britannica lists the planet as Herschel, notes the alternative names, and then proceeds to carefully word the rest of the article to avoid naming the planet again. But you, dear modern viewer, know that eventually these alternatives faded and left this name triumphant. Which leaves someone like me, with my terrible pronunciation, longing for history to have taken a different path. The name Herschel might have made the planet sound a bit like a boring accountant rather than the very interesting planet it actually is, but this would still be a much better name than what we have. Neptune is obviously a fine planetary name, though picking this might have just delayed the problem. Finally, the Georgium Sidus is a bit awkward, and in sillier moments, I wish that Herschel had just been more direct and named it King George, because how fun would that make it to teach kids the list of planets today? Mercury, Venus, Earth, Mars, Jupiter, Saturn, King George, and Neptune. In classrooms, such an unusual name would change the planet from a thing to avoid to a starting point for discussions about what makes that planet different, and how astronomy and our view of the universe change and progress over time. But my practical dreams aside, we're stuck with this name, which for me means choosing between the pronunciation which comes naturally and is terrible, or the unnatural, awkward one which is still unsatisfactory. So what's a man to do? In the end, probably follow the lead of the Encyclopedia Britannica and avoid the name when possible, which is a sad fate for the planet in our solar system with such an interesting story to tell.
Uranus.
Hey Vsauce, Michael here. What is the biggest number you can think of? A Google? A Googleplex? A milli-nillion? Olplex? Well, in reality, the biggest number is 40. Covering more than 12,000 square meters of Earth, this 40, made out of strategically planted trees in Russia, is larger than the battalion markers on Signal Hill in Calgary, the 6 found on the Bobbin badges in England, even the mile of pi Brady unrolled on Numberphile. 40 is the biggest number on Earth in terms of surface area. But in terms of amount of things, which is normally what we mean by a number being big, 40 probably isn't the biggest. For example, there's 41. And then there's 42, and 43, a billion, a trillion. You know, no matter how big of a number you can think of, you could always go higher. So there is no biggest last number. Except infinity? No. Infinity is not a number. Instead, it's a kind of number. You need infinite numbers to talk about and compare amounts that are unending. But some unending amounts, some infinities, are literally bigger than others. Let's visit some of them and count past them. First things first, when a number refers to how many things there are, it is called a cardinal number. For example, 4 bananas, 12 flags, 20 dots. 20 is the cardinality of this set of dots. Now, two sets have the same cardinality when they contain the same number of things. We can demonstrate this equality by pairing each member of one set 1-to-1 with each member of the other. Same cardinality, pretty simple. We use the natural numbers, that is 0, 1, 2, 3, 4, 5, and so on, as cardinals whenever we talk about how many things there are. But how many natural numbers are there? It can't be some number in the naturals because there'd always be 1 plus that number after it. Instead, there's a unique name for this amount: Aleph Null. Aleph is the first letter of the Hebrew alphabet, and Aleph Null is the first, smallest infinity. It's how many natural numbers there are. It's also how many even numbers there are, how many odd numbers there are. It's also how many rational numbers, that is, fractions, there are. That may sound surprising, since fractions appear more numerous on the number line, but as Cantor showed, there's a way to arrange every single possible rational such that the naturals can be put into a 1-to-1 correspondence with them. They have the same cardinality. Point is, Aleph Null is a big amount, bigger than any finite amount. A Googleplex, a Googleplex factorial to the power of a Googleplex to a Googleplex squared times Graham's number? Aleph Null is bigger. But we can count past it. How? Well, let's use our old friend, the supertask. If we draw a bunch of lines and make each next line a fraction of the size and a fraction of the distance from each last line, well, we can fit an unending number of lines into a finite space. The number of lines here is equal to the number of natural numbers that there are. The two can be matched 1-to-1. There's always a next natural, but there's also always a next line. Both sets have the cardinality Aleph Null. But what happens when I do this? Now, how many lines are there? Aleph Null plus 1? No, unending amounts aren't like finite amounts. There are still only Aleph Null lines here because I can match the naturals 1-to-1 just like before. I just start here and then continue from the beginning. Clearly, the amount of lines hasn't changed. I can even add 2 more lines, 3 more, 4 more. I always end up with only Aleph Null things. I can even add another infinite Aleph Null of lines and still not change the quantity. Every even number can pair with these and every odd number with these. There is still a line for every natural. Another cool way to see that these lines don't add to the total is to show that you can make this same sequence without drawing new lines at all. Just take every other line and move them all together to the end. It's the same thing. But hold on a second. This and this may have the same number of things in them, but clearly there's something different about them, right? I mean, if it's not how many things they're made of, what is it? Well, let's go back to having just one line after an Aleph Null sized collection. What if, instead of matching the naturals 1-to-1, we insist on numbering each line according to the order it was drawn in? So we have to start here and number left to right. Now, what number does this line get? In the realm of the infinite, labeling things in order is pretty different than counting them. You see, this line doesn't contribute to the total, but in order to label it according to the order it appeared in, well, we need a set of labels, of numbers, that extends past the naturals. we need ordinal numbers. The first trans-finite ordinal is omega, the lowercase Greek letter omega. This isn't a joke or a trick. It's literally just the next label you'll need after using up the infinite collection of every single counting number first. If you got omegeth place in a race, that would mean that an infinite number of people finished the race, and then you did. After omega comes omega plus 1, which doesn't really look like a number, but it is, just like 2 or 12 or 800. Then comes omega plus 2, omega plus 3. Ordinal numbers label things in order. Ordinals aren't about how many things there are. Instead, they tell us how those things are arranged. Their order type. The order type of a set is just the first ordinal number not needed to label everything in the set in order. So, for finite numbers, cardinality and order type are the same. The order type of all the naturals is omega. The order type of this sequence is omega plus 1, and now it's omega plus 2. No matter how long an arrangement becomes, as long as it's well ordered, as long as every part of it contains a beginning element, the whole thing describes a new ordinal number. Always. This will be very important later on. It should be noted at this point that if you are ever playing a game of who can name the biggest number, and you're considering saying omega plus 1, you should be careful. Your opponents might require the number you name to be a cardinal that refers to an amount. These numbers refer to the same amount of stuff, just arranged differently. Omega plus 1 isn't bigger than omega, it just comes after omega. But Aleph Null isn't the end. Why? Well, because it can be shown that there are infinities bigger than Aleph Null, that literally contain more things. One of the best ways to do this is with Cantor's diagonal argument. In my episode on the Banach-Tarski paradox, I used it to show that the number of real numbers is larger than the number of natural numbers. But for the purposes of this video, let's focus on another thing bigger than Aleph Null, the power set of Aleph Null. The power set of a set is the set of all the different subsets you can make from it. For example, from the set of 1 and 2, I can make a set of nothing, or 1, or 2, or 1 and 2. The power set of 1, 2, 3 is the empty set, 1, and 2, and 3, and 1 and 2, and 1 and 3, and 2 and 3, and 1, 2, 3. As you can see, a power set contains many more members than the original set. 2 to the power of however many members the original set had, to be exact. So, what's the power set of all the naturals? Well, let's see. Imagine a list of every natural number. Cool. Now, the subset of all, say, even numbers would look like this. Yes, no, yes, no, yes, no, and so on. The subset of all odd numbers would look like this. Here's the subset of just 3, 7, and 12. And how about every number except 5? Or no number except 5? Obviously, this list of subsets is going to be, well, infinite. But imagine matching them all 1 to 1 with a natural. If, even then, there's a way to keep producing new subsets that are clearly not listed anywhere here, we will know that we've got a set with more members than there are natural numbers. A bigger infinity than Aleph Null. The way to do this is to start up here in the first subset and just do the opposite of what we see. 0 is a member of this one, so our new set will not contain 0. Next, move diagonally down to 1's membership in the second subset. 1 is a member of it, so it will not be in our new one. 2 is not in the third subset, so it will be in ours, and so on. As you can see, we are describing a subset that will be, by definition, different in at least one way from every single other subset on this Aleph-Null-sized list. Even if we put this new subset back in, diagonalization can still be done. The power set of the naturals will always resist a one-to-one correspondence with the naturals. It's an infinity bigger than Aleph-Null. Repeated applications of power set will produce sets that can't be put into one-to-one correspondence with the last. So it's a great way to quickly produce bigger and bigger infinities. The point is, there are more cardinals after Aleph-Null. Let's try to reach them. Now remember that after omega, ordinals split, and these numbers are no longer cardinals. They don't refer to a greater amount than the last cardinal we reached, but maybe they can take us to one. Wait, what are we doing? Aleph-Null? Omega? Come on, we've been using these numbers like there's no problem. But if at any point down here, you can always add one. Always. Can we really talk about it, this endless process, as a totality and then follow it with something? Of course we can. This is math, not science. The things we assume to be true in math are called axioms. And an axiom we come up with isn't more likely to be true if it better explains or predicts what we observe. Instead,
Guys, wait, I will be.
it's true because we say it is. Its consequences just become what we observe. We are not fitting our theories to some physical universe whose behavior and underlying laws would be the same whether we were here or not. We are creating this universe ourselves. If the axioms we declare to be true lead us to contradictions or paradoxes, we can go back and tweak them or just abandon them altogether, or we can just refuse to allow ourselves to do the things that cause the paradoxes. That's it. What's fascinating, though, is that in making sure the axioms we accept don't lead to problems, we've made math into something that is, as the saying goes, unreasonably effective in the natural sciences. So to what extent we're inventing all of this, or discovering it, it's hard to say. All we have to do to get omega is say, let there be omega, and it will be good. That's what Ernest Zermelo did in 1908 when he included the axiom of infinity in his list of axioms for doing stuff in math. The axiom of infinity is simply the declaration that one infinite set exists, the set of all natural numbers. If you refuse to accept it, that's fine.
In the early 20th century, the German scientist Alfred Wegener noticed that the eastern coast of South America and the western coast of Africa fit together nicely, almost like two pieces of a puzzle fitting together. Then Madagascar fit nicely around the side of Africa, while parts of India seemed to have a place as well. Despite heavy criticism, Wigner went on to publish the book The Origin of the Continents and Oceans in 1915, pushing the concept of what he called Urkontinent, meaning supercontinent in German, except in a 1920 edition of the book where, for a single time, he called the land the Pangaea of the Carboniferous, coining the term from the Greek pan, meaning the entire or all, and Gaia, meaning earth. Of course, it was the Latinization of this word that became the more common phrase now, Pangaea. And today, Pangaea and the larger theory of plate tectonics are more or less common knowledge. Beyond that, though, I don't know if I've ever actually seen a good prediction on what the continent actually looked like. Most maps you'll find are either too simplistic for my taste or just an artistic representation of Pangaea, which can trade accuracy for aesthetic. So what I'd like to do today is make a rough estimate of what some of the geography of Pangaea was like, and hopefully by the end we'll have a cool map or something. Obviously, this will just be an approximation based on what we know so far about the supercontinent. So with that in mind, let's get started. First, Pangaea itself existed for around 160 million years, forming around 335 million years ago and breaking apart roughly 175 million years ago. Over this time, Earth's geological engine was still turning underneath, meaning that on a geologic timescale, Pangaea would have been constantly changing, and so one general map of Pangaea can't really be made. Instead, we're going to need to pick a specific time in Pangaea's past to look at. This one's going to be a bit arbitrary, but we're going to aim for between 190 million years to 230 million years ago. This was around the time of the Triassic-Jurassic extinction event, during which 20 to 30% of all marine species went extinct. For this time, the most accurate map for Pangaea I could find was this one. But using this, we can now begin to look at specific features, and to start, I'd like to look at some of the mountain ranges that would and would not have existed during this time. For starters, nearly every major mountain range on Earth today had not formed yet. The Himalayas, for example, only began to form 50 million years ago when India collided with Asia. And overall, it was the tearing apart of Pangaea that actually gave us many of our mountains. And the reason these all happen to be our tallest is because they haven't had enough time to erode. So to find out what would have been around during this time, we need to look at some of the oldest mountains remaining on the Earth, such as the Appalachian Mountains of the United States, the Little Atlas Mountains of Morocco, and the Scottish Highlands of Great Britain, all of which are nearly 500 million years old. Now, it just so happens that these three mountain ranges would have formed a single continuous mountain range across the
Wait, let's go to Atlas Flow.
How many continents does the Earth have? Some might think this is an easy question, but it might not be as simple as you think. If you ask an American like me, you'll probably get the answer of 7. North America, South America, Europe, Africa, Asia, and Australia. Oh yeah, and Antarctica. But ask a person from South America and they might say 6. America, which is just one continent, Europe, Africa, Asia, Australia, oh yeah, and Antarctica. Then someone who knows a lot about geography might tell you that nothing really divides Europe and Asia, so there are only 5 continents. America, not mine but your Asia, Africa, Australia, oh yeah, and Antarctica. And technically, before the Suez Canal was dug, Africa and Eurasia were connected by land as well, so some people like to say that there are only 4 continents: America, Afro-Eurasia, Australia, oh yeah, and Antarctica. But then, there are some who would argue that all of these have still left out a continent, the 8th continent, the continent of Zealandia. Within the Pacific Ocean lies a scrap of continental crust that is raised more than 1 kilometer higher than the surrounding oceanic crust and is geologically distinct from any and all surrounding bodies, completely separated from Australia by the Quito Trough. It's nearly 5 million square kilometers in area, which means it's nearly 2 times larger than Greenland and nearly 2/3 the size of its neighbor Australia. And while it might look like it's covered in water, well, it is. But it's not made of oceanic crust. It's made up of continental crust, the same thing you and I are sitting on right now. The only problem is that today, out of those 5 million square kilometers of continental crust, 94% of it lies beneath sea level, and only the continent's highest mountains remain above the ocean, which form the islands of New Zealand and New Caledonia. In all, there's only around 350,000 square kilometers of Zealandia above sea level today. That's less area than the US state of Montana. But it wasn't always this way. For millions of years, Earth's land surface was split between 2 major How many continents does the Earth have?
Okay, wait.
Some might think this is an easy question, but it might not be as simple as you think. If you ask an American like me, you'll probably get the answer of 7. North America, South America, Europe, Africa, Asia, and Australia. Oh yeah, and Antarctica. But ask a person from South America and they might say 6. America, which is just one continent, Europe, Africa, Asia, Australia, oh yeah, and Antarctica. Then someone who knows a lot about geography might tell you that nothing really divides Europe and Asia, so there are only 5 continents. America, not mine but your Asia, Africa, Australia, oh yeah, and Antarctica. And technically, before the Suez Canal was dug, Africa and Eurasia were connected by land as well, so some people like to say that there are only 4 continents: America, Afro-Eurasia, Australia, oh yeah, and Antarctica. But then, there are some who would argue that all of these have still left out a continent, the 8th continent, the continent of Zealandia. Within the Pacific Ocean lies a scrap of continental crust that is raised more than 1 kilometer higher than the surrounding oceanic crust and is geologically distinct from any and all surrounding bodies, completely separated from Australia by the Quito Trough. It's nearly 5 million square kilometers in area, which means it's nearly 2 times larger the size of its neighbor Australia. And while it might look like it's covered in water, well, it is. But it's not made of oceanic crust. It's made up of continental crust, the same thing you and I are sitting on right now. The only problem is that today, out of those 5 million square kilometers of continental crust, 94% of it lies beneath sea level, and only the continent's highest mountains remain above the ocean, which form the islands of New Zealand and New Caledonia. In all, there's only around 350,000 square kilometers of Zealandia above sea level today. That's less area than the US state of Montana. But it wasn't always this way. For millions of years, Earth's land surface was split between 2 major landmasses, Gondwana and Laurasia, the fragments of the Greater Pangaea. Zealandia was part of Gondwana and made up roughly 5% of the supercontinent's total land area. Then, as Gondwana began to break apart to become modern-day South America, Africa, India, and Australia, oh yeah, and Antarctica, Zealandia split away as well. But as these continents moved apart, some of them, like South America and Africa, were pushed against themselves, so they became more narrow but also taller. Then the opposite happened for the other landmasses. So Antarctica and Zealandia were stretched longer, making them thinner, kinda like stretching a rubber band. Because it was made thinner than the rest of the continents, Zealandia floats lower in the Earth's molten mantle, just beneath modern sea levels. But this means there was a time around 180 million years ago, just when Gondwana was beginning to break apart, that Zealandia was in its full form and proper height above the oceans. 55 million years after it split from Australia, however, Zealandia had become almost completely submerged. Because of this, a lot of people dismiss Zealandia as a true continent, despite it being a huge piece of continental crust. So let's take a look at what the criteria is in order to be considered a continent and see if Zealandia qualifies. While it might seem easiest to look at tectonic plates of the Earth to decide our continents and oceans, a second look reveals this to not be very helpful at all. Some plates contain large portions of both land and ocean, like the South American plate, which is over 50% submerged, and also there are a number of smaller plates that none of us would consider to be full continents, like the Caribbean, Nazca, or Juan de Fuca plate. So we need to look somewhere else to find what a continent truly is. The idea for Zealandia was first introduced in 1995 by Bruce Lyondike and was expanded upon by Nick Mortimer and his team of researchers in a paper titled Zealandia, Earth's Hidden Continent, which was going to be the name of this video until I decided to try to be a little more original than that. But in this paper, the basic outline of what constitutes a continent is given. First is that a continent must have an elevation above that of the ocean floor surrounding it. A quick look at any ocean floor elevation map will show Zealandia's shape rising more than a kilometer over the surrounding ocean. So on that point, Zealandia gets an easy pass. Second is more a geological rule, saying the crust of the continent must contain a wide range of igneous, sedimentary, and metamorphic rock. This is to keep islands and oceanic plates out of the running. Things like volcanic islands are basically all igneous rock, and ocean crusts are usually mostly basalt, another igneous rock, so they're both disqualified. Rock samples from the sunken continent revealed plenty of variation in rock type, so Zealandia gets another pass. Third, the continent must be thicker and less dense than oceanic crust, and therefore have a lower seismic velocity. As we've seen, while the crust making up Zealandia is thinner than other continents, it's still noticeably thicker than the surrounding oceanic crust. Because of its geological makeup, we just talked about, it's also less dense than oceanic crust. So again, pass. The fourth and last criteria is a continent must have a well-defined extent that is large enough to qualify it as a continent rather than a microcontinent or continental fragment. An example of a microcontinent would be the island of Madagascar off the coast of Africa, still very large but not quite large enough. And this is where we run into a little trouble because, well, what exactly qualifies as continent size? Well, let's take a look. Australia is the smallest quote-unquote official continent at 7,692,000 square kilometers. So any and all landmasses bigger would definitely be a continent. Then the biggest island would be Greenland at 2,166,000 square kilometers. Anything smaller would definitely not be a continent, but rather another island. But Zealandia falls somewhere in the middle, bigger than the biggest island but smaller than the smallest continent. This sets up an interesting question. Does a landmass only have to be bigger than Greenland to be a continent, or greater than or equal to Australia to be a continent? Bigger than 2 million square kilometers or bigger than 8? We've never needed a more exact definition because no landmasses between these two sizes exist today, although in prehistoric times the Earth was littered with them, like India and Arabia. Nick Mortimer's paper offers 1 million square kilometers as a possible cutoff, which would also qualify Greenland as its own continent, so I don't like it. Plus, this number is rather arbitrary, with essentially zero geological basis. Why 1 million? Why not 1,000,001? Why not 999,000? And so on. Even more people dismiss this claim, however, based on the sole fact that, while yes, the entire shelf comes in at nearly 5 million square kilometers, most definitions of continent include something along the lines of massive expanse of land, of which Zealandia has very little. But the proponents of Zealandia argue that if we studied Earth and its continents like we do for other planets, ignoring surface liquid, Zealandia's status as a bona fide continent would become apparent because it's still so much higher than the surrounding ocean crust. I think the overarching issue is that we don't really have a good definition of what makes a continent. And this is because, well, they're kind of made up. We invented the idea long ago when Earth was just land and sea with nothing in between. But now we have Sealand, Zealand, Zealandia. Boom, got it. And that's why no one today can agree on what exactly a continent is or even how many of them we have. So what do you think? Should Zealandia be considered Earth's 8th continent? And exactly how many continents do you think there are? Let me know in the comments.
Okay, I will also type. Wait.
And if you liked this video and want to see more, hey, how about liking and subscribing to this channel? I'll be back next week with another video. Thanks.
After 30 days, I could not believe my before and after picture. I literally rolled back the hands of time 10 years. When I first saw this product, I thought it looked kind of crazy. Didn't really understand what the benefits would be, but I had seen some before and after pictures on the website and thought to myself, you know what, I'm 48 years old, my face is starting to look a little bit aged, wouldn't hurt to try. So, and the best way I can explain this product is it's like something you've never experienced. You have about 40 pounds of resistance right there. Now I'm pushing that down as hard as I can, but when I put it in my mouth and exercise, my jaw can handle that kind of pressure, no problem. So what I discovered is that after using this product, after maybe 100 or 200 reps, all of a sudden I feel all this blood flow coming into my face, into my scalp, and a couple things happened. Number one, I felt a lot more awake and energized. It was a great stress reliever, but if it wasn't for the before and after picture, I probably wouldn't have totally seen the dramatic change that happened in my face. So Brandon was nice enough to take, I live here on Maui with Brandon, he was nice enough to take a before picture, and then about 30 days later, we took an after picture, and the results are absolutely amazing. So what I believe he has stumbled upon here is a massive discovery. If you think about it, there's a piece of fitness equipment for every other part of your body, right? And why isn't there one yet for the face? And now that there is, it totally makes sense. When you work something out, you bring in blood, you bring in blood flow, you strengthen things. Over time, collagen, reproduction drops, things start to sag. This device, because of the activation, the 40 pounds of resistance, all of a sudden creates a fit face. And I believe that it's going to revolutionize fitness and beauty and the way that we think about staying in shape. So aloha, Brandon, thank you so much for inventing an amazing product.
The Earth's climate is changing. This is a fact. As the planet warms up, ice will melt, ocean waters expand, and storms become more energetic, altogether pushing more water onto land than ever before. While the degree to which sea levels rise is still highly dependent on the action we take now and in the immediate future, elevation maps are old news, so we don't need to wait to see what will happen if we don't reverse our carbon output. From the year 1900 to 2016, the ocean rose by approximately 21 centimeters, while the human population rose from 1.5 billion to over 7 billion, and carbon emissions went from 2 billion tons to 36 billion tons annually. All this means is that we're going to observe even greater increases in sea level year after year for the rest of the century, with estimates of a 38 centimeter rise by 2100, which by my calculations should be near the end of yours and my lifetime. Meaning these are the lands that we all have to worry about right.
Sing! Aywa. Wait. But something wrong happened! And this is the end. Thank you for watching, and subscribe the bell button below, and we will see you on the bright side of life. Wait. It's the end.